Hi guys, very good afternoon. In this video, we shall discuss about soil water crop relationship. The soil, water and plant are important natural resources very vital for the survival of the men and animals. These three resources need to be managed scientifically and efficiently for maximizing food production to meet the requirements of ever increasing population. The aim of irrigation practice is to ensure that the plants have an adequate supply of water in their root zone for achieving optimum yield of crops without damaging the quality of the soil. This necessitates a clear understanding of the interaction among the soil, water, and plants in the root zone of the plants. Soil. Soil is the natural medium for the growth of plants. It is a natural mass of unconsolidated material on Earth's surface. On Earth's surface, formed by physical and chemical disintegration of surface rock formation. The soil provides a structural base to the plants and allows the root system to get firmly embedded in the soil. Further, the soil also provides water for transpiration as well as the minerals for nutrition and oxygen for metabolism required by the plants for their growth. Soil profile, you can see on the screen. Look at the picture. You can see different zones, that is the soil profile. The soil consists of various layers different in color and composition known as horizons. The succession of horizons is called profile of the soil. The development of soil as end product of the process of decay and decomposition of rocks proceeds through three recognizable stages. These stages appear as a series of zones in any section of the soil. These zones are layers approximately parallel to the soil surface. Such zones, arranged in descending order, indicate different stages in the development of soil which collectively constitute soil profile. The three zones beginning from the surface downward are zone A, zone B and zone C. Zone A, it is a zone of leaching and decomposition in which the minerals and organic matter are decomposed and converted into colloids. It is characterized by finely divided particles extending from a few centimeters to 60 centimeter below the surface. It is the zone in which the grass roots, etc., are embedded on it. It contains humus in moist region. The zone has maximum biological activity. The block layers is generally 20 to 30 centimeter thick. Next is zone B. It lies immediately below zone A. It is a zone of deposition. It extends from few centimeters to 100 centimeter thickness. It varies from zone A: color, structure, clay content, and organic matter. Organic matter is low. The main size is rather coarse. Third layer is zone C. It is the layers of unconsolidated material like decomposed rock or freshly deposited alluvium. It is characterized by a coarse grained, rather pebbly texture, marking a transition between actual solid rock and the finally decomposed rock. Roots penetrate into this zone. It extends usually up to 2 meter in thickness. The hard and compact zone is called as the R zone. Physical properties of soil. The physical properties of soil is color, texture, structure, porosity, permeability, pH of the soil, depth of the soil, and infiltration capacity. Physical properties of soil. The color. First one is color is one of the most useful and important characteristics of soil identification. Color of the soil depends upon its composition, drainage condition, porosity and age. Concentration of organic matter imparts a gray, black or dark brown color to the soil. Diffusion of iron oxides imparts red and yellow color to the soil. Manganese dioxide and hydrate iron oxides may also contribute red color. A light gray color may indicate a very low content or organic matter and iron. Effective drainage tends to change these colors appreciably. Soil color changes with moisture content. The next physical property is texture. The size of particles comprising the soil determines its texture. The texture of a soil is perhaps its most nearly permanent characteristic, although soil structure can be quickly modified by management. The texture commonly refers to the fineness or coarseness of soil as a whole as to the proportion of the particle group of different sizes. It is controlled by climate and mineralogical composition of the parent rock. The four textural types of soil generally recognized are coarse sandy soils, fine sandy soils, silty soils, and clayey soils. Loamy soils has mixed particles of sand, silt and clay. In nature, soil is seldom made up of one group. Depending upon the clay content, soils are classified as light, medium, and heavy. For soil type, light, percentage of clay present is 2 to 10, and water requirement for irrigation suitable for crops with less water requirement. For normal or medium type of soil, clay percentage will be 10 to 20%, and the water is requirement ordinary. For heavy soil type, the clay percentage is more, that is 40 and above. Large quantity of water at regular interval is required. In light soil, the crops jowar, bajra, pulses, sesame, groundnut, fodder, mustard, etc. Normal or medium soil type, crops grown is cotton, wheat, gram, maize, oil, seeds, peas, vegetables, etc. In heavy soil type, the rice, sugarcane, etc. will be grown. The next physical property of soil is structure. It signifies the arrangement of soil particles, sand, silt, clay, organic matter, etc. in soil mass into porous compounds called aggregates, which are separated by pores and cracks. The soil structure is important to soil productivity, soil permeability, root growth, and soil genesis. The common types of soil structure are granular, prismatic, blocky, and massive. Granular, fine-grained soils have granular structure in which water enter is rapid with better seed germination and as such are desirable for irrigation as large voids provide space for circulation of air. Prismatic. In prismatic structure, the movement of water is mainly vertical and as a result, the water supplied to the root is poor. Blocky. In blocky topsoil, water entry is moderate. Massive. In topsoil, massive structure blocks the entry of water. Seed germination is difficult and aeration is poor. From the standpoint of agriculture, permeability of soil to water, air and roots provided by favorable soil structure is important. Favorable soil structure is the key to soil fertility. The fourth one is porosity. Porosity is defined as the ratio of volume of voids to the total volume of soil mass including that of water and air. It is expressed as percentage. Voids ratio is defined as the ratio of volume of voids to the volume of soil solids. It is expressed as a ratio. The porosity of the soil varies with structure of the soil, size, shape and gradation of soil, presence of organic matter. Voids in the soil influence production through their effect on water holding capacity of the soil, movement of water, movement of air, spreading of roots. The fifth factor is permeability. It is an important quality of the soil that enables it to transmit water or air. It is defined as the velocity of flow under a unit hydraulic gradient it depends on. Presence of minute openings in the soil, size of the openings, shape of the openings, arrangement of openings, water temperature, soil texture, and soil structure. The next physical property is pH of the soil. pH value or negative hydrogen ion concentration is a measure of the intensity of acidity or alkalinity of a soil. Its value ranges from 0 to 14, of which 7 is neutral, in the sense of chemical reaction below 7. The soil is acidic, above 7 it is alkaline. Soil productivity increases as pH approaches neutrality. The seventh physical property is depth of soil. Sufficient depth of soil for the storage of irrigation water and penetration of roots is essential. Shallow soils require frequent irrigation for optimum growth of crops. Deep soils of medium texture and granular structure provide for the adequate storage of water and root penetration and sustain relatively long periods between irrigation. Soils of arid regions are relatively deep compared to humid regions. The last physical properties of soil is infiltration capacity. It is very important factor. Infiltration capacity of a soil is the maximum rate at which soil is capable of absorbing water in a given condition. Infiltration capacity is expressed as centimeter per hour over an area. Larger the voids, greater is the infiltration capacity. Vegetated soils have more infiltration capacity. So these are the physical properties of soils. In the next session, I'll discuss about soil classification. Thank you.